Hey, welcome back to Math Mini Lessons. In today's lesson on area, we're going to look at irregular polygons. So we had originally started with just using rectangles, but we saw that sometimes we can have a shape that is not a rectangle. And how do we find the area if we can't see the tile? So while I'm working, I want you to look to see how I decompose an irregular polygon. That means, how do I break it up into smaller pieces? And how I accurately calculate the area and find the total area. So let's jump into our first model problem. A shaded array and an unshaded array are combined to create the picture below. Which expression can be used to find the total area in square units of the shaded figure? So I'm looking only at this irregular figure right here. How can I find the area? So we talked about decomposition, and what that means is we know how to use multiplication to find the area of a rectangle. But what if we have a shape that has right angles, but it's not a rectangle because it has all these extra sides? So what that means is we're going to cut it into smaller pieces. So I'm going to cover this. This is not important right now. And I want you to see how you can cut this piece and think about it like you were slicing a cake. Where would you slice it? So you'd have two rectangles or just rectangles and squares. And I want you to just think about it. I can cut it this way, and now I have two pieces and I can find the area for both. Or you can cut it this way. So there's two possibilities. So let's see which one can actually work. I'm going to actually, for the first one, decide to cut it this way, straight across. And if I do that, now I have A and B, and I can figure out the area for both parts. So I can do the area for A and then find the area for B. And in this case, it would be, let's see, this part is a 2 by 2, so 2 times 2. And then plus, this part is a 3 by 5. 3 times 5. So that's one way I can find the area for this irregular piece. So you can capture this part down. What could be another way? I could cut it, let's say I cut it this way. And if I did that, here are my pieces now, A, B. So to find the area for A, it would be 2 by 5. So 2 times 5 plus 3 times 3. And so now I have two ways. Even though I cut it, I have two different ways I could have cut the shape and decomposed it to find the area. Does that change the area? Would I get a different answer for either of these? Well, let's see. With the first one, 2 times 2 is 4, and 3 times 5 is 15. So 4 plus 15, which is 19. Let's give it a little bit more space because I know I want to be super clear with my work. And in the second one, I have 2 times 5 is 10, and 3 times 3 is 9. So in both of these cases, look, I get the same answer, 19. So it doesn't matter how I decompose it, how I cut it, the area is going to be the same. All right, so that's all they were asking here is how I can represent it. So let's look at the choices and see which can work. So in the first one, it said I can do 2 times 2 times 3 times 3 times 5 times 5. That doesn't make any sense. And just looking at how they probably got those numbers, they looked at all the dimensions. So they probably went, so here's 2, and here's 2, and here's 3, and here's 3, and here's 5, and here's 5. So that doesn't work. So in a shape like this, you can't just go and take all the different sides and just multiply these together. That is not going to give you the area. That doesn't make sense. And it's going to give you a super big number. Just think about it. If we were able to get 19, if I just did 2 times 2 times 3, so that's already 4 times 3 is 12, times 3 is 36, already is too big. So no, A doesn't work. You can't just multiply all the sides around. So that doesn't work. Let's look at the next one. 2 plus 2 plus 5 plus 3. So here, notice they're adding, and that's not going to help us find the total area because that's not going to tell us about the number of squares inside the shape. So that doesn't work. 2 plus 2 plus 3 plus 3 plus 5 plus 5. All right, so they're adding up all the sides. That's actually perimeter. So nope. That's perimeter, not area. And the last one, you have the 2 times 2 plus 5 times 3. So that's what we had right here. So that actually works. So again, notice all we're doing for irregular polygons is we are cutting it. We are slicing it into 2 rectangles and finding the area of those pieces. And that's what happened here. It was a cut to get a 2 times 5 to get these 10 plus this 3 times 3. All right, hit pause and jot this down into your notes. All right, this one is going to be a little bit more complicated because I do not have the tiles now. So I'm still going to cut, I'm still going to decompose and add, but I don't have my tiles. So let's see what we can do here. The shape below the shape shown below was created by combining 2 rectangles. So I know it's combined, so I'm going to separate them. What is the area in square feet of the shape? So again, you can decide how you want to cut. You can either cut this way or you can cut this way. Does not matter which way you want to do. I'm going to decide just to cut this way. So this 8, I'm going to cross it out because now my 8 is being separated into 2 different numbers. So from here to here is going to be 4. How do I know? Because I look at the other side. I'm looking at the opposite side. And from here to here, this is also 4. And that makes sense, right? Because the total part was 8. And now I've separated into 2 pieces, a 4 and a 4. So now let's figure out A and B, the areas for A and B. So A, and then B. I'm going to find the areas for both. So 4 times 4 is going to give me the area for this part, 4 times 4. And 4 times 10 is going to give me the area for B. All right, so now I can actually solve for those. 4 times 4 is 16. 4 times 10 is 40. So my total area is 56 square feet, which is here, C. All right, so again, the things I really want you to think about is when I made my cut, I looked to see what number got cut, what dimension. And here, when I made this cut across, it did cut this dimension into 2 different pieces. My 4 didn't get cut because it went from here to here, and this one also doesn't get cut. What I can find is 2 separate pieces and then find the total area. All right, hit pause and jot this down into your notes. All right, now it's your turn. In guided practice, you have a diagram of Ryan's yard. Which expression can be used to find the total area? All right, hit pause and try this out for yourselves. Okay, so let's actually get into it. Which one can give us the area? The answer for this one actually is, ta-da, D, 12 times 10 plus 5 times 4. And the way I did this, I had to look at each one and think, like, what can I immediately eliminate? And I know that A and B, I'm adding these numbers instead of multiplying, so this is not going to help me find area. So automatically I eliminated A and B. In C, I had 12 times 10. So I know that we're looking at this part 12 times 10 as a rectangle. So it would be as if we cut here. And then they had minus 5 times 4. And that's not what we're looking for because we're trying to add these 2 pieces together, not subtract. So that's why C doesn't work. But D actually works because we have, a good question. How do you know it's not 10 and not 14? Why do you know that? Well, because I'm looking at the slice here. This is decomposing this 14 into 2 smaller pieces. And I know this part is 10. And so that means the rest of it has to be 4. Now I can do my part, my area for A, my area for B, and that's 10 times 12. And I'm adding the other piece, the 5 times 4. And that's how you would have gotten D. All right, That's it for today, Math Marbles. Notice for these irregular shapes, they're going to have right angles so that you can make rectangles out of them. That's what you're going to see at the 3rd grade level. I hope you found this helpful. Again, doesn't matter how you cut, but if you have a problem that has different types of expressions, look to see if yours doesn't match. It could be that they cut it in another way. So I hope that hint helps you out. That's it for today. Make sure you're showing all your work so you can follow along and share it with your peers. And I hope you found this super helpful, Math Marbles. I'll see you in the next one. You got this, guys. Be well. Bye.